Hey everyone, this is Mr. Dufresne here. To get us started, I need to erase this stuff still. I'm learning some new tools. This thing is called, I think, Magic Pen. Is that what it's called? Magic Pen? Probably, okay. And it allows me to write anything I want. So if you're right on the notes here, because my document camera died on me, or at least my computer no longer registers me as having the document camera connected. If you have never heard of Murphy's Law, I strongly recommend that you look it up. It's a good thing to keep in mind for life. Tends to happen a lot to me. So yeah, look at Murphy's Law. Good thing to look up. Okay. Let's get started on this. So my name is Key, and my handwriting's not super great on this. I'd like to get a pad where I could just kind of write freehand like Sal Khan does in the Khan Academy videos. On the note of Khan Academy, by the way, they're having some money issues because with all the students doing work at home now, a lot more teachers are using Khan Academy or sadistic parents. It's hard to tell. And, they only have so much funding. They don't make any money off of what they do, and they have to provide server space for traffic. So if any of you want to donate, it's a nice thing to do. I went ahead and threw $25 their way. I'm not super rich, but I think about all the time that Khan Academy has saved me as a teacher in preparing assignments, and I also think about what I've gotten out of it. There are definitely lessons I have gotten from Khan Academy in mathematics that helped me out. Like right now I'm going through their statistics and AP statistics classes, because even though I'm getting a master's degree in statistics and my stuff is a lot harder than anything Khan Academy has to offer, it's kind of like skipping to calculus and you never took Algebra 1 and Algebra 2. So there are things that maybe I don't, reciprocal, things that I don't know, or little gaps in knowledge that I have. And Khan Academy has helped me patch those holes up, and they're not charging me anything for it. Whereas my university is charging me, like $40,000 from education. So I figured giving Sal Khan $25 for all Khan Academy has done for me is a pretty fair deal. Graphing reciprocal functions is today's lesson. It took me a long time to write that. Hopefully I'll get a little better at that. Today's date is, let me get my phone. What is today's date? It's, let's see, April 6th. So 4/6. And this is for Algebra 2, like always. Okay, I feel like I had something else I was going to say, too. Oh, I'm sure it'll come to me. That's okay. Now, hold on. Do you see that dot's changing? That's my mouse wheel. I'm going to have to take some time to get used to that. Well, let's see. If I close this now, and I go down, and my thing, and I pop this up, is the writing still there? It is. Okay. So I think what I'll do is, hold on, I don't want, go away. There we go. I made it go away. Do not show again. Okay, so I'm gonna keep this up here. Perfect. Look at it, it's like I never moved. And I'll fill this whole thing out down here, and then I'll move it down, and I'll erase everything at once, okay? So it's not so messy. So the reciprocal function is f of x equal to 1 over x, okay? And this graph looks kind of funny. The nice thing about me doing a lecture like this is now I can show you things on other tabs later. And let's do f of x equals 1 over x. Look at that graph. That's pretty weird looking, right? This is called a hyperbola. So if we go back to our, this is called a hyperbola. Wow, look at that great handwriting. Go me. Okay. And if you look at the hyperbola, where's my hyperbola graph? There we go. You'll notice that it kind of looks, if you go around here, it looks like it approaches 0 asymptotically, right? If you look over here, you can see it's getting closer and closer and closer to 0. And at some point, it looks like it goes into 0, but it never does. Like, look at this point. My y value is still 0.03. And eventually, Desmos will tell it's 0, probably out here or something. Oh no, 0.018. 0.017. So it'll never hit 0. It will eventually, but that's only because it's rounding down. Really, it never hits 0. And similarly, as it goes up, it looks like it's going up asymptotically. Look at that, 0.03635. So my x values are getting closer and closer to 0, but they're not getting all the way there. And same thing here, right? This is approaching 0 asymptotically on the y's, and down here we're approaching 0 asymptotic on the x's. So in 4 directions, the reciprocal graph is approaching an asymptote, and really we represent the asymptote with 2 lines. There's always going to be a vertical asymptote and a horizontal asymptote, okay? And the vertical, hold on, x, let me make sure I get that right. X is 0, y can be anything. Yeah, the vertical asymptote is easy to figure out, okay? All you have to ask yourself is, what can x not be, okay? If you think about it logically, when I say what can x not be, this is a fraction, right? And we are dividing. And there's a rule about dividing fractions, right? We can never divide by what? Good job, you got it. It's 0. We can't divide by 0, okay? So what that means is that this graph has a vertical asymptote at x equals 0, okay? And, where's the horizontal asymptote? You guessed it, it's at y equals 0, right? If y is 0, here's my asymptote here going across, and I even type it just y equals 0, and you can see, boom, there's my horizontal asymptote, okay? So let's get that in there. My horizontal asymptote is y equals 0. And now we want to graph. And whenever we do graphing stuff, I always tell you guys, we make a function table. Whoa, didn't mean to do that. You know what though? Let's go with it. Let's make it, oh crap, not that big. Okay, that was, there you go. We'll make it a little thicker, but not too thick. Too thick and we can't handle it. Okay, so here's x, and here's y, or f of x, whatever you like to write. I don't know. I like y, personally. Having the 2 x's up here sometimes messes with me, even though I've been doing this for a very long time. So I like y more. But I wrote f of x here, so I'm going to write f of x down here to be consistent. And, usually when we are graphing things, I give you a policy that's something like, let's find a starting value and go 2 up and 2 down. And that's similar here. We have a starting x value. What is that starting x value? Well, it's the x value we're not allowed to use, which is 0, okay? We aren't going to do 0 because we can't do 1 divided by 0, but we're going to go around 0. So we're going to do -2, -1, 1, 2. And let's see what these points end up looking like. Well, if x is -2, then f of x is negative 0.5. And if x is negative 1, 1 divided by negative 1 is negative 1. If x is 1, 1 divided by 1 is 1. And if x is 2, 1 divided by 2 is 0.5. And I know what you're all thinking right now. You're all thinking, silly Mr. Dufresne, we're just going to use our graphing calculators anyway. And that's true. But at least I'm doing my end of the bargain and showing you how to do this stuff. By the way, super impressive test scores. Class average is like a 97% across the board. I guess this distance learning stuff just really suits you guys, right? So let's mark these points. X is negative 2, f of x is negative 0.5. Let's change my color here to red or something to help it show up. X is negative 2, f of x is negative 0.5. Well, that shows up pretty good. X is negative 1, f of x is negative 1. So I got negative 1, negative 1. And I got 1, 1. So here's my 1, 1. Here's 2. I wrote 0.2, but I should have been 0.5. 5. Right? You can't even tell that was a 2. Wow, that's like the best 5 I've ever drawn. All right, continuing on. Which color was I using? Was it this dark red? I think so. And then 2, 0.5. 2, 0.5. Right here. That's definitely not the same red. Which red was it? Was it this one? Yeah, looks good. Okay. 2, 0.5. And that's not very good, is it? So to really graph these well, you want to check some more points. And so I'm gonna I can't just scroll down because everything, you know, the writing doesn't stick. So I'm going to make like an extra table over here. Oh, in the wrong color. It'll take me a while to use these new tools, but I'm a smart muffin, blueberry muffin, preferably from Sam's Club. Those are really good blueberry muffins if you haven't had them. And let's do some extra values. And what I want to do is I want to get a good view of the asymptote. So let's do another like x equals 3. Let's do and x equals negative 3. So I'll do 3 and negative 3. And I also want to get a good view of this asymptote right here. So I'm going to do, let's do 0.5 and negative 0.5. And I think those points will get us a pretty good view. So if x is 3, well, this is 1/3, right? And if x is negative 3, it's negative 1/3. And if x is 0.5, it's 2. And if it's negative 0.5, it's negative 2. So if I graph these, switching back to, look at me, I'm catching already. I switch colors ahead of time. If x is 3, f of x is 1/3. So we at 3, 1/3. And then negative 3, negative 1/3. And then we also have 0.52 and negative 0.5, negative 2. Okay? And from that, like, that's pretty good. You got a good idea of what things look like right here. Okay? Don't expect good graphs from me when I'm drawing. Remember, I'm drawing with a mouse. That's a serious math teacher handicap to have. Okay, and that's what it looks like, all right? So all of them are going to look like this. The domain, I really think it's a good idea to write your domains like this. If you want to use the old way, you know, we used to write like how would I write this? X can be negative infinity, right? X can go to positive infinity, but there's a hole at 0. So the old way that we'd write this is for domain. I'll write D for domain to save myself some pain. Negative infinity, wow, that's good, to 0, comma, 0 to infinity. And that's like a lot of writing, I think. And the thing is this, tomorrow, or for 8.6, you might have some graphs, or maybe it won't be until the reviews. I haven't looked at the problems thoroughly, but by the end of this week, you're gonna have some graphs that have multiple gaps in them, like multiple x, not asymptotes, but multiple x values you can't have, which means you'd have to do 3 of these parentheses, 3 of these ranges right here, and I think that's just cumbersome. So what I recommend you do is write it like this. My domain, you put it in braces, and you can see my braces here are just as good as they are in the classroom. X, you write X, that lets us know what we're talking about. Then you put a vertical bar, and that means such that X is not equal to 0. Wow, that's the worst one I've ever drawn. And so what this means, this is read as X such that X is not 0. And what that really means is when we're looking at X, X just can't be 0. So anything else goes. So basically for a domain, instead of listing what it can be, this is can, we list what it can't. And that counts. That's okay. Okay, and I think this is just much better. And I'll just tell you guys, spoiler alert, for the test, we all took 2 questions and made them. And I chose domain and range, and I formatted the answers like this. So if you don't get used to it, you probably won't know what to do on the test. So it's not just a good idea, it's a really good idea, okay? Otherwise, you're going to be in trouble. Range, same idea. What range is y value? So it's y such that y, and what can't y be? Well, y, we have an asymptote at y equals 0. If we have an asymptote, that's a value that we can't have, so y cannot be 0. Okay? So that's the basic idea of what we're doing today or tonight, because for me it's a little after midnight. So I'm gonna close. I think I'm gonna erase all this. Yeah, I erase, because if I just close it, it'll be back when I pop up on the next thing. So I'm going to erase all this. Woo! 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 Okay. Mr. Dufresne's having a good time in quarantine. Okay, so I'm gonna close this, which is me go back to here, and I can scroll down. Ooh, look at that. We got standard form. How exciting is that? Don't you guys just love standard form? All right, so for a hyperbola, remember that's the kind of graph that we just looked at as a hyperbola. Standard form is, whoops, it's a big one. Small one. F of x is a over x minus h plus k. Now I know what you guys are thinking. You're thinking, oh my god, another standard form. How in the world will I remember all of this stuff, Well, it's similar to vertex form for a parabola, which I know you guys have memorized because you have nothing better to do, right? And think about this. We got the plus k, and, in our past graphs, in our past transformations, what has plus k done? Plus k or minus k has moved things up and down. So k is the vertical shift. Now you have to wait while I slowly write it. Vertical shift. And as you'd expect, plus shifts it up, and minus shifts it down. And let's prove that, shall we? I like proving things to you. Okay, so I've got my, get out of here. I have 1 over x, let's make it plus 5. Well, look what happened. Moved up 5. 4, 5, 4, 5, 4, 5, 4. Let's do 1, 0, plus 1, 0, 1. Oops. 1, 0, 1, 0. Okay, what if I do negative 1? Look, it goes down 1. Minus 5. It goes down 5. So I proved it to you. You can no longer question it. That is law. All right? Where's my thingy? There we go. Okay, so K shifts up and down. I showed it to you with the plus on Desmos. H is the... Can you guess? No, it's not that. It's the horizontal shift. Why would you think it's a diagonal shift? Sometimes I think you guys just aren't listening at all. Horizontal shift. And the other shifts, remember, everything was backwards, right? If something is plus, you would expect that it goes to the right, because that's where positive numbers are. But actually it does the opposite. It shifts things to the left. So this is left. Yeah, that's good. And this is right. Okie dokie, Spanny-okie. And I'll prove that to you too. Okay, here's my x. I'm going to make it minus 1. So minus 1 should go 1 to the right, right? Oh, there it goes. See? Get rid of it. It's in the center. Minus 1. Now we have a vertical asymptote at x equals 1. Now, why is the asymptote at x equals 1? Remember I told you, the rule of division, you can't divide by 0, right? Well, if it's x minus 1, what x value makes us divide by 0? It's when x equals 1. So if I make this like minus 4, right? Well, now my vertical asymptote is at x equals 4, because 4 is the x value that we cannot have, because it would result in dividing by 0. So if you forget, just think about dividing by 0. We can't divide by 0, and that will tell you, set this equal to 0. X minus 4 equals 0, right? Add 4 to both times, x equals 0. Now you know. There we go. Let's bring the magic back. I wish I could, like, when I click this button, that fireworks could come out. That'd be cool. Okay. Let's see. If a is negative, can you guess? The function is... Yes, you remember. Good. Reflected. Oh man, I wish I could just edit that out, right? Alright. If a is negative, their function is reflected across the x axis. I'm going to prove that to you real quick. If I make this, I'll go back to my 1 over x. Make it negative. If you roll fast, it makes like a cool little diamond shape or something, right? Power star. Oops, I just lost everything. It's all destroyed now. But we're back. Soon. We're back. Good, got it. Okay. You didn't see that. And coming from the history of transformations, if A is 1, that represents a vertical stretch. Right, we're stretching things out. Wow, that looks weird, doesn't it? That's how you spell stretch. It just looks weird. You're right at word, and it just doesn't look right. You know, like bus. Bus. What a weird word. Okay. And if A is between 0 and 1, or rather, I should say, the absolute value of A. That was supposed to be circling the absolute value sign. The absolute value of A, not just A. So remember, if it's negative, that doesn't count as stretch or compression, right? That's your reflection. Okay, negatives don't stretch or compress, they reflect. It's all about the value of A, not its sign. So if A is between 0 and 1, that's a vertical compression. Okie doke. And so the vertical asymptote we already talked about. The vertical asymptote is x equals h. And what you should think of is if I have x minus h, it's not okay for this to equal 0. So if I do x minus h equals 0, this is what's not okay, right? I can't have x minus h end up as 0. Well, if I solve this by adding h to both sides, I now have x equals h. Yay! And the horizontal asymptote is just y equals k. Okay, so whatever this k value is, that gives us, I can just draw all over this. Let's go wild. In yellow. Gross. Whatever that k is, that's also our horizontal asymptote. Okay? Okay? Okay. Well, even if you don't agree, and that's just the way it is. So I'm sorry you feel that way. Okay. Our reciprocal parent function is reflected across the x-axis. So we have f of x equals, and what's happening to it? We know it's going to be a fraction. Let's just throw the fraction bar in there, okay? Let's get that over with. It's 3 units down. Okay, 3 units down. What's that look like? That's minus 3, right? And it's translated 4 units to the right. That's positive 4. So for positive 4, we want x minus 4. And then it is reflected across the x-axis. So that means it's a negative a, or negative 1 since that's the parent function. There's our graph. That's it. I'm only going to do this one because there's only 3 of these, and I want you to get some practice with them. I don't think they're super hard, but you should get used to it. And it says identify the asymptotes. So what are my asymptotes? Well, this is k. My horizontal asymptote is, let's get more colors. More colors solve everything. Y equals k is my horizontal asymptote. What's k? This is k, right? So my horizontal is just y equals k. Oops, which is, negative 3. Ha ha ha, duh. And then, if what x value makes this not possible, x is 4. So x equals 4 is the vertical asymptote. Now, just as a heads up on the test, I think the teachers are inclined to just write VA colon bar and HA for vertical asymptote and horizontal asymptote. So make sure you're prepared for that and don't get, you don't miss points for silly things like just not knowing an abbreviation. I'm done with green. I don't know about you guys, but I'm going back to blue. It's had its time. Oh, I get to erase again. Maybe I should get some music going for that, Go on YouTube, play a little song. Can you believe a couple months ago I had never seen a Marvel movie, and now I'm all the way up to Ant-Man and the Wasp. I'm almost done. We'd be done already, but Roman's really big into the superheroes, and he's not going to handle it well when some of them die, in the Avengers movies. In fact, the last time that he saw a movie where a character he died, he pointed at me and he yelled, what was it? Daddy, this is a terrible movie. You knew they were going to die. You knew it upset me. This is all your fault and I hate you. And he ran out of the room. So, it probably won't go super great when he watches that. How long is this recording so far? Does it actually say? 29 minutes, 55 seconds. Okay, so I don't think I'm going to do... I think I'll just do 2 of them maybe. And I'll let you guys pick which ones. What's that? You want me to do the first one because it's so easy? Well, if you insist, okay. I figured you'd want me to do the hard ones, but I guess I'll do the easy ones. I'm not going to argue, okay? So, okay, there's the VA and HA, right? Let's see, maybe I'll do... I think I'll do 4 and 8. I think I'll do 4 and 8. You know, because it's not that many problems, right? 1, 2, 3, 4, 5, 6. Yeah, so I'll do 4 and 8, and I'll leave the rest to you guys. So here's that VA HA thing, and you could see. So what's our horizontal asymptote, right? The horizontal asymptote. Let's remind ourselves. Horizontal. Oh wait, my writing's gone. No, I don't know anything. I'm just kidding. The horizontal asymptote is y equals k. So what's my k? This is my k, which is -2. So horizontal is y. Oh, look, it's thicker all of a sudden. Whatever. Y equals -2. And the vertical asymptote, right? The vertical asymptote comes from the denominator here. Well, that's just x equals 0, right? I can't divide by 0. If x is 0, that's not okay. So that's just x equals 0. Oh yeah, fun fact. The very first video I put out last week had something like 130 views on it. Like, wow, you know, it must be super popular because I only have 85 students. I guess you guys just, you know, maybe rewatch it when you're bored or alone at home. You're like, yeah, I just miss Mr. Dufresne's voice. He just makes me feel all toasty inside or whatever. But by the last video, I only got 22 views total. So, I don't know. Maybe you just didn't need my help for the review. That's how I'm going to choose to interpret that. Right. And so what's my domain going to be? You know, it's here. The domain and the range, like they're lined up. Range is y's. Horizontal asymptote is what y can't be. Right? So my range is just y. That's pretty good, isn't it? If I try... Yeah, I feel like it looks worse now, even though I fixed it. Whatever. Y such that y is not equal to -2. Yeah. And in domain, what can't x be? It can't be 0. So it's just... let's pretend that's a brace, okay? X such that x is not equal to 0. My zeros, I think, are pretty dang good. I don't know you guys, but I'm feeling impressed with myself, okay? So, one thing you can do, okay? And I taught you how to do it with a function table. This is an easy one, right? This isn't tricky math. So instead of doing a function table, I want to not trick you. I do that enough, right? I want to show you guys a trick that can help you. So where's my horizontal asymptote? My horizontal asymptote is y equals -2. So at y equals -2, here's my horizontal asymptote, okay? And my vertical asymptote is x equals 0, which, you know, well, that's working good, okay? And now let's go to Desmos to see what I'm really trying to show you. You know, I had asymptotes at y equals 0 and x equals 0. Oh, why does it have to be? It doesn't show it well when it's and it's red. X equals 0. Blue. Oh, that's pretty good. If I close these, okay, good. I just wanted some color contrast there. You know, you can look at this. Here are my asymptotes, and you just draw curves along those asymptotes that don't touch the asymptotes, right? One curve top right, one curve bottom left. Okay? So, if I'm doing this, right, where are my curves? I got one curve top right with arrows, and one curve bottom left. Okay, it should be like a little... You know, that's so wrong. I gotta fix that a little bit. That's just... I'm okay with being sloppy, but not that sloppy. Okay, that looks much better. So there you go. Boom, we're done. I mean, and that's what I mean, like, if you're looking for a rough graph, because you guys know on your test, a lot of the time when we do graphs on tests, we're just saying, like, hey, which graph represents this function? Well, if you can do the transformation and know that it's -2, and this is 0, and these are asymptotes, then boom, you're done. That's our graph. You know, we don't have to do anything more. Questions? You sure? Okay. Well, yeah, if you're good, I'm good, you know. Just checking in, gotta make sure. I'm gonna redesign the eCampus page soon. I hope you guys like it. Should look pretty snazzy. Okay, so I'm gonna do one more. And someone requested number 8. Was it? Okay. I guess I'll do number 8. Only because, you know, you requested it, right? So the same rules apply. What's my horizontal asymptote? Horizontal asymptote is based on k. So this is -7. That's y equals -7. I like to do this stuff before I draw the graph. For the transformations, when it's like this stuff, usually I like to draw graphs first, but for reciprocals, it's like there's so much division. Gross. And we can't let this be 0. So if it's x plus 4, x being -4 is not okay, right? So I have x equals -4. So what's my domain? You know, that's just going to be x such that x is not -4. And this is going to be y such that y is not -7. I think it's go up back and forth a lot, and you know, I call it a brace. And now we make a function table, woo, super long one, of x and f of x. Okay, and I'm gonna make this thing a little skinnier. And again, what's not okay? X can't be -4. So let's do points around -4. What's around -4? Well, -5 and -3. So I do -5 and -3. And let's do another one each direction. -6 and -2. So I'm doing things around this x equals -4 vertical asymptote right here. Well, if x is -6, -6 plus 4 is -2, 2 to the -2 is -1, minus 7 is -8. So this is -8. -2, -2 plus 4 is 2, 2 divided by 2 is 1, 1 minus 7 is -6. -5, it's probably going to be a decimal, right? -5 plus 4 is, oh no, it's not. Wait, -5 plus 4 is -1, 2 to the -1 is -2, minus 7 is -9. Oh, okay. Fine, I'll be wrong. -3 plus 4 is 1, 2 divided by 1 is 2, 2 minus 7 is -5. So let's mark our first values here and see what things look like. So I have -6, -8. How many points are this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. I don't know you guys, but I find it hard to count lines. They all just blend together for me. But now that there are 10 total, instead of counting out -6, I can start -10, do -10, -9, -8. Wait, -10, -8, -9, -6. -6, right? Yeah. So -6, -8, like I can just look at how far away are from -10. And that's like, that's easier for my brain. Oh, no, I didn't mean to, it's okay. I don't really care. -5, -9, so I got -5, -9. -3, -5, so I got -3, -5. -2, -6, -2, -6. Okay, now let's think about where the asymptotes are real quick to help us out. Okay, like what other points do we want? Well, I got one at y equals -7 here's y is negative 7. So this is going to be one asymptote. And then if x is negative 4, here's x is negative 4, and here's my other asymptote. And so you can see things are going to look, there's going to be like a curve here and a curve here, right? On this one, like number 9 right here, because it's negative 1, this will be flipped. You'll have parts up in the top left and the bottom right. So it's still good to do a function table, because you don't want to just look at the asymptotes and then draw curves. Okay, it's good to do function table stuff. So let's get some other values in here. And I think it's good enough to do like 4 for each curve. I'm happy with at least. So my next value is going to be x is negative 1. Like I want to know what's right here. So let's do x is negative 1. I also want to know what's right here, right? Let's continue this curve. So that's x is negative 7. And then the other points I want to know what's going on right here. Like how's this curving up here? And so I'll do, this is negative 1, 2, 3, negative 3.5. And then over here, I want to know how this is curving down. And that's 1, 2, 3, 4. This is 5, right? So negative 4.5. Yeah. And I think if you get these, it'll look pretty nice. So let's do the math. If x is negative 7, negative 7 plus 4 is negative 3. So I have negative 2/3, gross, minus 7, so negative 7 and 2/3. So I have negative 7 and 2/3. So where's that? Let's do all the math first, okay? This is one we haven't done yet. Otherwise I'll lose track with my simple brain. And negative 1 plus 4 is 3. 2/3 minus 7, that's negative 6 and 1/3. So negative 6 and 1/3. And we haven't plotted this one yet either. Negative 3.5. Negative 3.5 plus 4 is 0.5. 2 divided by 0.5 is 4. 4 minus 7 is negative 3. Yay! Whole numbers. And negative 4.5 plus 4 is negative 0.5. 2 divided by negative 0.5 is negative 4. Negative 4 minus 7 is negative 11. It's going off our graph. That's okay. That's okay because we can handle it. We can do this, guys. Oh, let's star these. Okay. So negative 7, 2/3. Let's go back to my red. Negative 7 and negative 7 and 2/3. So it's like right here. And then, so we got that one. Negative 1, negative 6 and 1/3. Negative 1, negative 6 and 1/3. Got that one done. Negative 3.5 and negative 3. Negative 4.5, negative 11. So here's negative 4. Negative 11's like right here-ish. Okay, it doesn't have to be perfect. But boom, look at that. We got a great curve going here, guys. Okay, it started out good. Started out good. I expect yours to be perfect. Okay. So, in summary, use the asymptotes to guide you by thinking out transformations and do some function tables. Okay? And that's all I got for 8.6. I hope you guys have a good night.